So how many of you are using microservices in Angular? Just one? All right, two, three. All right, excellent. That's helpful. All right, so if you've read about microservices, you probably read about articles, for instance, about how big should a microservice be. So one of the answers would be no bigger than bounded context in a domain-driven development, which is actually a pretty huge thing. Or some people say that it should be no larger than what a two-pizza team can build quickly and one person maintain. That's another answer. Some people say a couple of hundred lines of code in an expressive language. That's again pretty tiny. So if you go out to the web and you read a blog post about what size should my microservices be, you're not going to get much smarter. In a sense, all those answers are correct, because microservices is an architectural concept, and architecture is on multiple levels. So they're both correct and they're wrong. But that's something that we're going to talk about today. So real microservices, how we've designed them, and what kind of challenges come up when you do them, and then that will kind of reflect on these kind of topics, like what should the size be. Today we're splitting the time between me and my colleague Dmitry. I'm starting with a short introduction to Zalando and Zalando Tech. Then I'll move over to talking about designing a microservice in the first steps and really looking at those first hurdles when you're working in a microservices environment. And then Dmitry will continue with a more in-depth architect's view into herding a set of microservices. So Zalando, I think almost everyone knows that Zalando is a web shop selling fashion. When you go to zalando.fi, you see a fashion store. That's true. Zalando is a huge web shop. We have 20 million active users in 15 countries and 3.6 billion in revenue. So yeah, Zalando is pretty huge. That word sounds funny after the US elections, but anyway, yeah, huge. But that's only part of what we do. So we have a platform, we have significant logistics capabilities, we have our own labels in Z labels, and we have multiple customer-facing applications that provide different opportunities for users to interact with fashion. But Zalando is also a huge tech house. So we're around 1,600 people strong in the tech organization, and we built most of Zalando in-house using microservices and agile teams that use the coolest technologies available. So we have a lot of Scala, Go, Clojure, building on AWS and Docker, and so forth. Zalando, this picture is actually from our Berlin office, but we have also an office in Helsinki and Dublin. And the Helsinki office is fairly new, a couple of years old, around 80 people, and really a gang of superstars doing a lot of good microservices. Okay, so let's get to the beef of my topic. So, designing a microservice. This quote is from the classic No Silver Bullet paper. And the point that Mr. Brooks made in the paper is that there is no order of magnitude improvement coming in software development. So he's talking about the essential and the accidental complexity in software development and comparing that to the order of magnitude improvement that we've seen in hardware. But in software, that's not really happening. And it's because there's a lot of both accidental and essential complexity. So complexity coming from the problem expression and complexity coming from the tools we use for it. Microservices is a similar thing. It's not an order of magnitude improvement on anything, but it's actually just an incremental improvement where you make a trade-off. Make a trade-off between scalability of teams and scalability of services by increasing complexity. So this is kind of where my story starts with the Death Star. Many good stories start from there. The Death Star is in microservices context. It's about imagining drawing a network of your microservices. So imagine a microservice going around the radius of the Death Star. And then you draw lines between all microservices that are communicating together. Ta-da, you draw a Death Star. And that's really a microservices anti-pattern. If you have atomic, small microservices that are doing individual things, and you're calling between them all over the place, you have a lot of problems. Well, not a lot of problems, but a few. So one of the problems is that if you call one thing, you want to do one thing. You call something on the rim, and that calls another thing, and you have this huge chain of calls. And you don't really know who owns the complete latency and how the predictability of that system is really, really difficult to understand. Another problem is that if you have multiple services that are doing similar things, so say you're handling order transactions, and you need to create the orders in multiple places. So when you're creating the order in one place, you need to call 5 or 6 microservices, and you're orchestrating how they operate together. And then you have another service that's also creating an order, and they're doing the same thing, calling the same services. So you're creating these orchestrators, this middleware, all over again in all the different services. So you might be doing the same bugs again, same problems again. So my Death Star is about customer-facing applications and content sources. So imagine that you have customer-facing applications on one side, you have content sources on the other side, and you have context enrichment and response enrichment on both sides. So basically, when you get a request from a customer-facing application, you might add behavioral data to that user ID, you might add user information, and that's sent to the content sources. Then the content sources know what to respond with, and they respond with JSON, and then you enrich that with related data or with images or things like that. So that's my Death Star. We're crisscrossing all these requests, even though we have multiple CFAs, customer-facing applications, that want very similar things. So what would be a solution for the Death Star? So maybe putting a corset on it. So you have the Death Star, you put a corset on it. That's a good sense idea, right? You put a central piece there, something central through which you route the messages that are coming from the customer-facing application to the content sources. Then you start thinking about all the options that you get from that. Like there's so many things from a product point of view. You can start serving the content faster because you might be caching something there. You might allow for rules-based decisions on what to show. And those rules could exist in that central point. And the central point could allow for all kinds of really nice features for translating the content from one source to the other. And if you're thinking about the enrichment could be cached in the middle. So you're winning. You're winning from a technical point of view. There's cool challenges. From a product point of view, you're in a central location where you can really make an impact on business. So we started drawing some architectural pictures, and this is what we came up with. And well, yeah. Then we were nauseous. A lot of people say that microservices is just service-oriented architecture. Well, in a sense, yes, it is a service-oriented architecture, but a service-oriented architecture built on an enterprise service bus is not the same thing. And if it's built on top of the enterprise service bus, the enterprise service bus is not a microservice because it has multiple different things that it's doing at the same time. And that means that that thing, that one thing in the middle, it can't scale with new teams because you can't release it independently. And it can't scale for speed horizontally, independently from each other. So if your routing component would need to scale, but your rule engine would not, you can't scale them independently. And if you need to release a new version of your rule engine, but not of your routing component, you still need to create new versions and release the whole thing. So you're creating a monolith in the middle. And if everything that you're building is built on top of the monolith, that's not really where you want to be. So that's not really what we did. We took to the Occam's razor, and I think that's really the message for microservices in general. That if you're designing something that's complex, that has multiple pieces in the same place, and you want to still be really scalable, and you want to be able to just throw more engineers on the task, you really need to make atomic services that are doing individual things well, and then you can pack those with engineers. And if you need to do another thing, you create a new team and you put that team on that thing, and that's its own service, its own microservice doing its own thing. And that's my story. So thank you for my part. I'll hand over to Dmitry, and we'll take questions in the end. So if you have something for me, keep it in mind.
So hello. Well, what's the microservices? So we kind of very important message what we just heard, that there are no silver bullet for microservices. Every company draws its own story. What's the common in microservices? That helps you to streamline your business, to purify the concept of your architecture and kind of deliver the product in time. Things what I'm going to talk you here is about how we apply the microservices in search area, and not going very deeply, just kind of giving the highlights on certain aspects what you have to consider in your daily business, hoping that it would help you. Then one important story what was said by Jori, it's about autonomous teams. The team's autonomous, they deliver something. If there are no control on the team, you know what they're going to deliver? Death Star. And then what's the role of architect in the microservice environment? It's in the sense I see it's a guy who look on the team, who helps the team to do the decomposition of the complex problem in the set of microservices, the guy who looks into non-functional requirements, and a guy who ensures how to scale the things. Let me tell you my story. So, the search. What is the search in Zalando? Well, it's basically the front landing experience, the first things what the consumers see. It's a discovery path for consumer, and our search is quite big, so we're handling millions of operations per day, and I can also tell you things if search is down, you cannot get the new products, you cannot put the products to shopping cart, you're losing a lot of money. And in such a way, the microservices helps us to kind of improve the business impact. Just before jumping into the microservices and how we did that in search, I would like to emphasize that search in our business is different than search in the normal web. We cannot bring the consumer the big search box. The guys don't know what to type there. You have to inspire the consumers. And things, because the guys don't know how the fashion things are called. Believe me or not, but I spent maybe several minutes just to type this in. How you can expect that ordinary guys can type something, can search. No way. So that's why search is kind of more complicated. You have to consider different use cases. And in that sense, the business story use cases, it's a good point to start the decomposition of the complex problem into set of microservices. The user journey use cases give you the headline, and it defines you the boundaries where you can cut. As an example, in enterprise business, the search was kind of, it's not a primary case for search, right? And most probably, the enterprise architect would go out and buy the search solution as a kind of ready-made box from third parties and so on. In that sense, you just see search as a feature, as a box, and kind of what else you can split as a microservice. Unfortunately, some executives have same opinion, but I can tell you, search is a swarm of microservices. It's a hardest swarm, it's a stateful swarm. Let's look how we can, what principles we can take in to split stateful solution into set of the microservices. Here, the traditional patterns comes in, and I would say the layered principles also works here nicely. The stateful services, let me take a 12-factor application as an example here. I'm going to speak in that context. Stateful microservice can be represented as a collection of stateless processes, baking services, and some admin processes. So the whole concept of the baking services is a resource that holds a state. Here we come as a clear storage layer, or as a kind of clear storage block, whatever you call it, cloud. The point that it's a single place that keeps a state for your solution, and then also very important to mention that it's not keep the state for the whole swarm of microservices. It's a state for single service. It's just a resource from microservice perspective. Again, what you should do, really, kind of just take open source of the shelf component to build this storage box. Go to Amazon, get the ready-made things there. That's an answer. Then you probably read in the blogs that the microservice is actually about the event-driven approach. That's absolutely true. Kind of, we have an event buses that holds the data and facts about our goods, about our products, what we have. And then, as a microservice designer, you basically go to domain-driven approach, and you think, what's the data important to execute a given function, and what are the transaction boundaries for your data? And then you design your storage, and then you design your microservices around that. And then you design your intake pipelines to extract, transform, and load data in that context. You're not making a generic ETL frameworks to power your single microservice. Just do small things like Jori mentioned, team of the pizza-sized team can implement the intake pipeline in a week. It's not serious business. Okay, trash it. So another study what we got that often people say that, hey, the microservices is about REST architecture. Well, possibly yes, but then how come you would implement all possible use cases? The lesson learned from our side that microservices is about different interface technologies. We figure out the fives. So, of course, you need the REST, and the REST is the primary tool. You serialize the JSON, and that's your primary tool. However, you need the queues. Some of the, you need to integrate your microservices to your databases. If we are talking about some artificial intelligence or compute-intensive microservices, you cannot bring them online. You need to bring them behind the queues. Here we are. I talked to you about the storage layer, right? It's primary for microservices key value interface. Well, obviously, we need traditional databases, Elasticsearch, Solr, whatsoever. So you need a kind of query interface with a DSL capability, which depends on some technology. Finally, the logs. So that's a kind of 5 important classes of interfaces, and you should carefully look on them while you handle design. Then it's very often people forget about the data. The data is also interface. You should forget that your data is a kind of monolithic blobs. In order to deliver the successful story of microservices and split microservices to swarm of services, they need to talk each other. How they can talk each other if you don't have a clear protocols, if you're not you cannot in these blobs, you cannot model, say that, hey, all of us talk the same language. It's impossible. But what you can do, you can say that we have a certain rules about the data. We know how the data looks like, what's the look and feel of the data, and then we can use that to build a so-called common data notation. As an example, we are in some of our solutions, we are looking to aspect of semantic web because it brings this kind of feeling that the data is not a monolith, and then it defines you the notations of the data. Why we need that? Because we need to ensure interoperability. So they need to talk not necessarily same language, but kind of same patterns. We need to ensure evolution because we're different with a different fashion data sources, and the fashion domain is very flexible. So we bring to the new partner, and then we have to integrate the partners on board. Well, and then of course the isolation of the data, like once you do the microservices, they shouldn't interfere each other. All in all, you would see that you would gradually move to linked data approach. So that's right. I was kind of been talking about the functional side here, but then if you think that non-functional aspects is a feature, what you can deliver later, then you would get pretty much the same outcome. In the microservice environment, the non-functional requirement defines you the certain quality criteria, how you handles the design of these services, so how you interconnect the services together, how you tackle aspect of scalability and latency, especially the latency, because it becomes a big problem in the microservice environment. You trade off design complexity to kind of complexity in the network, and therefore complexity on the communications. If you forget to tackle this aspect, then you would deliver unusable swarm of microservices that would possibly fulfill the business requirement, but would not be usable for customer. Some practices regarding the how we handle the delivery of microservices. I would say that immutable deployment is an answer to your question. You should treat infrastructure as a code. I believe the time when we had admins who SSH to some node and kind of do the tuning here, they're gone. You cannot scale your business, you cannot scale the microservices if you have that set up. Everything what you do for microservice, it's written as a code. Either as a code, a set of scripts, either as a code, kind of using the cloud technology. As an example, Amazon has very nice support on that, and we built our immutable deployment solely on Amazon environment. So there is a challenge here. You need to have a great tooling. You cannot achieve immutability if you don't have an excellent orchestration layer. And the orchestrations, of course, right now, kind of we're seeing that there are some kind of open source frameworks on the horizon that kind of delivers that orchestration. I'm referring to the Kubernetes as an example here, and then also Amazon is working on that area. But it's the things what we learn, it's not necessary enough just to kind of take Amazon API and then immediately it's ready for immutable deployment. We spent significant effort to develop our own tooling to manage the things. As a benefit, we spent significant amount of time, resources to bootstrap our immutable deployment. But then as a benefit, we got fault tolerance approach. So if we deliver the faulty software to our customers, we can roll back that in minutes. We can use parallel deployment to split the traffic to different versions of our software for A/B testing, for canary testing, and then kind of the gradual deployment. So, and then on top, another very important feature from microservice perspective is a graceful degradation. When something goes wrong, it shouldn't go wrong for the whole system. You should simply say to user, hey, we have a problems, and you should kind of disable one feature, but whole systems, the main use case is still up and running, and then deliver the value to consumers. And microservice is an answer to that problem, because as an example here, you see on this slide the division of the microservices in the search area. So, in search, you usually show the catalog page, and then you show some facet navigation and so on. And as an example, this facet navigation is its own the microservice. If it goes down, okay, well, it's bad. The user experience suffer, but still the main functionality for the search for content discovery is up and running, right? Then the search by itself might be modeled as a kind of the query planning, the query understanding layer that takes a consumer intent and then splits the intent to kind of analyze what it's about, apply some NLP techniques, and then forms the query to kind of structured search. Again, this principle helps us. If NLP do not work, okay, so whatever, this microservice is down, and then we still kind of deliver the search functionality. Of course, it's a kind of not such rich functionality, so the search wouldn't understand particular terms, but still you show some products to the users. Well, again, the caching layer can do these things, and so on and so forth. So the main message here that if you do the right split on the functional boundaries of your microservice and you develop the concept of the graceful degradation, then you can protect yourself from nasty disasters. And things what we told to you with Jori is like all good, all nice, kind of. But you know, the Black Friday is your exam. This event, and I'm pretty sure every enterprise has their own Black Fridays. These type of events, they would simply show, are you right or not? In our case, we already run a couple of Black Fridays with our microservice design, and system was up and running. All right. I think we should wrap down and go to questions, answers. I would like to say thank you very much for attentions, and you can read more about principles of our microservice design on in our blogs on the techzalan.com, and then also you can get in touch with our open source initiatives in the microservice area. Thank you very much.
Okay, thanks Jori, thanks Dmitry. So we can take some questions, but before I let any of you ask something, I was kind of thinking when you told about this, so I guess you haven't had the microservices architecture always. So could you tell us a little bit about the kind of transition and how was it kind of moving into this new model?
Sure. So basically, if we're looking at how the microservices evolved at Zalando, the original Zalando shop was a Magento off-the-shelf PHP open source thing, and with the first TV ad that crashed catastrophically and died, and then there was a group of 10-ish engineers who wrote the new shop in Java in 2 months, and then it was in feature parity with the Magento shop, but obviously far more scalable. That was the first version 5-ish years ago, and then we've had 2 iterations on the monolith, and the monoliths work well. It's kind of sad to see how, for instance, shared databases can actually serve a lot of customers super efficiently. And it's a real challenge when you're transforming your system into a microservices environment and you start putting things on different machines, on different databases, and calling all interaction with a common database completely forbidden. It makes things slower quite often. And how you actually build a system so that you get the scalability, so you're not degrading the system that much, but you still have the latency that comes from all the hops. And there are challenges, and we've been kind of traversing this climbing this mountain for a while. We're well over halfway, but I think if you want to hear like a longer story about our transition from the monolith to microservices, there's a good talk by Rodrigue Scheffer, who's one of our heads in Berlin, who ran the first checkout migration from the monolith to the microservices. So it's a very good talk that you can find on YouTube.
Okay. So any questions from the audience to Jori or Dmitry?
How does your tech stack look like? Or are you allowing teams freedom in choosing their own frameworks and data stores, or do you have some platform services that you provide to everyone and then they just choose, or how does that work for you guys?
Do you want to take that one?
Yeah, we do. So in the nutshell, the teams are autonomous. They can choose language, they can choose the framework, they can choose the data store. Obviously, there are some kind of I wouldn't call it limitations, but some rules of play. As an example, you should look primarily on Amazon. Then we have a certain expertise. As an example, we have a huge expertise on the Postgre database, and then it makes no sense for team to claim that, hey, I want to do on MySQL, because yes, you might have only one person who knows MySQL, but then like hundreds of guys who are experts in the Postgre. And then, of course, we have a certain platform services. So as an example, a payment is a very good example. You cannot say that, hey, use whatever payment. It's a kind of platform service. But then kind of I would say that we don't have a type of hosted platform services where they kind of anyone say that, hey, you should use this hosted service.
And I guess if they're kind of from more from like a language point of view, that's also something that feels awkward to people. That can you just use any language? So we do have kind of guidance from a central, like anyone can join a tech guild where those who are really excited about languages debate the merits of languages, and they have their own guidance in for instance, a tech radar where they say that actually these are the ones that we would prefer. But if you have a team that has solid expertise in some area and they can build a service and maintain the service and they can implement the identity and access management and anything that kind of we provide out of the box for instance, JVM languages, that if they have to be ready and willing to build those themselves. So then they're free to go. But yeah, I think mostly we're on the JVM and Golang, Python.
Okay, thank you. Anything else?
Hello, a question about the Occam's razor. The question is, how does making microservices atomic free you from repeating orchestration code in many places or having long call chains?
Yeah, that was kind of part of my talk, that it is actually leading to that. So basically, that's the kind of the Death Star is the epitome of you have atomic microservices and you are really doing that. But then the way to kind of work against it or kind of fix the thing in some cases is to come up with architectures where you can have some kind of orchestration layer or a middleware component, but that component should do just one thing and be only for this one orchestration. So that's kind of the story there behind that. It's hard, and really the atomic units are the key there, and they're valuable also because anyone can use just that one feature. They don't have to use the whole thing like they would if you would always have to go through an orchestrator. But you can still implement an orchestrator, and that's part of the architect's job or architecture part, that you really need to understand when it makes sense and how to choose where to put one of those things and what kind of couplings it will create between both the orchestration component, the customers, and the client or clients and servers.
And also one important point to mention here that once it's atomic, it's a disposable. You can dispose the things at any time, and then you're not anymore stuck to such legacy solution because nobody can maintain this, nobody knows the insights of the business logic. You just dispose it and then kind of bring the new team who can optimize it.
Mm. Yeah. Okay, thank you. Anything else? Oscar?
So I have a follow-up question. So when you have a bunch of services built by different teams and different technologies and different data stores, how do you maintain those in production?
Yeah, that's a good question. No, we do maintain them, and basically the idea is that the team has end-to-end ownership of what they build. So we have autonomous teams. The teams are built of senior developers, so we can really give a lot of responsibility to the team to really deliver end-to-end. And once the team has to work with the product side to really understand what our service is doing, they have to architect it, they design it, they come up with the scalability models, they run the test, they run the orchestration and create the CI, DevOps, everything, and then they maintain it, they monitor it, and someday, hopefully, they'll kill it. But that's really the team has the end-to-end ownership, and obviously when we have transfers, every now and then there's a situation where you need to transfer some maintained code to some other team. It's always challenging, and especially if you would have kind of ready pieces, like you'd go the Netflix road and have a very set palette of technologies, that would actually make a lot of things easier in that sense. But on the other hand, we are getting super good engineers because they want to work with the coolest technologies and they want to own up to the responsibility that they get. Like when you have a lot of freedom, you get a lot of responsibility as well, and that's really something we want to foster. We want to really build and agile teams that take responsibility.
Yes, I was called overnight several times. And also we kind of we cultivating the culture of the guilds where the people can share the information. Hey, we're having this API, we have that API, and then the API first principles on the development with a proper communication across the tech. It gives you possibility for discovery of and maintaining the information.
Okay. Anything else? If not, then I was kind of thinking, you mentioned that even if the teams are really autonomous, you have to have some kind of common guidance or some kind of common way to go. So can you describe what kind of practices do you have in that space, or what would you recommend to do?
I think we don't have that much guidance.
Okay.
So we do, like, it's when you grow to a certain size, like we're building a product with 1,600 people in tech, and it's really a huge amount of people, and it's a huge amount of teams. Like, you have hundreds of teams, and those teams are building components, and some components might be ready, and they might be running only in the Finnish market for certain customers, and you have old monolith services that are serving certain customers with certain devices, and then you have all these different pieces. So even if you would be drawing the architectural diagrams and you'd be saying that I will control this, you will not understand half of what's happening. And it's like the metaphors with a map. Like, well, once you're done with the map will be obsolete because the world has moved on. And that's a big challenge. But it also really comes from the Conway's law, that we really have the autonomous teams that are building as independent services as possible, so that then even if some team would be off or that component would be needed, then you're using another component, and you just need to make do. And I think the goals, like if as long as everyone's thinking about the customer and really trying to focus on what the customer needs and how do we solve problems and make money, then you have good guidance for the teams. Like even if no one knows exactly what that team is doing, where and how and when, we still know that they're working towards the same goal, and they're technically skilled people, and they have the support they need. So.
Oh, great. So thanks a lot, Jori. Thanks a lot, Dmitry. So now we'll have a break, and we're continuing at 11 with the next breakout. So
yeah. Right.
coffee
Thank
available. Thank you.